Hi, I'm Erica Mason, a doctoral student at the University of Missouri in the Department of Special Education. And today we're going to talk about conceptual understanding. So what is conceptual understanding exactly? Well, it's the measure of the quality and quantity of connections that an idea has with existing ideas. In other words, think about all the mathematical topics you have in your mind. How many connections are there between those topics? And what's the richness or the robustness of those connections? For example, think about the term decimals. So already you're probably thinking about examples of decimals or other mathematical content that you relate to decimals, like fractions or percentages. Maybe you're starting to compare and contrast those contents. What you're doing is you're making connections and exploring your own conceptual understanding of the concept decimals. So now that we've talked just a little bit about what conceptual understanding is, let's talk a little bit about why it's important. The National Research Council defines mathematical proficiency in terms of 5 interrelated strands: procedural fluency, conceptual understanding, strategic competence, adaptive reasoning, and a productive disposition. All of these strands by themselves are important, but together they define how we would characterize a mathematically proficient student. You'll notice that conceptual understanding is highlighted here. Conceptual understanding actually supports you in developing all the other strands of proficiency. For example, if you understand a mathematical concept, then a procedure might make more sense to you as to why it works. Understanding mathematical concepts can support you in choosing and evaluating the strategies that you use to solve math problems. Conceptual understanding absolutely supports you in reasoning about whether or not an answer makes sense. And lastly, if you understand mathematical concepts, you're more likely to see them valuable and connected to the world around you, which means you have a productive disposition towards mathematics. In addition to the National Research Council, the National Council of Teachers of Mathematics also described conceptual understanding in terms of the learning opportunities that should be afforded to all students. I've highlighted 3 of them here because these specifically relate to developing conceptual understanding. So the NCTM says that all students should have the opportunity to acquire conceptual knowledge, that is, to understand the underlying math concepts to problems. Another learning opportunity that all students should have is to connect new learning with prior knowledge. So again, we're trying to develop intentional connections between past learning and present learning. Finally, the NCTM encourages all teachers to present learning opportunities to students to engage with challenging tasks. And one aspect of challenge or rigor is making sure that students have the opportunity to understand and explain the underlying concepts of the math problems that they're working on. So let's look at an example that highlights the difference between conceptual understanding and rote memorization or recall. So look at this problem here, for example, 37 plus 28. Now, many students might be able to compute this accurately, and that's important. What's also important, though, is what are the students thinking about this particular problem? One thing that might come to mind is that this is a combining situation. That's really trying to understand what students understand about the concept of adding. So perhaps a student can't compute this accurately, but maybe they could talk to you about what it means to combine 2 different quantities. This problem could also be represented in multiple ways, and while it's interesting to look at the different strategies that students use, what's most interesting is what their strategy represents about their thinking. That is, what do they know about this mathematical concept? So I can imagine that one student might create 37 tallies, 28 separate tallies, and then combine them by adding them one by one. I can imagine another student representing this problem on a number line, and yet a third student representing this problem by placing it into some kind of real-world context. All of these representations are interesting, but what makes them interesting is the insight that we gain into what students understand about the underlying concept of addition represented in this problem. One student might even make the observation that you could take 37 plus 28 and actually represent it as 30 plus 20 plus 7 plus 8. That gives rise to all sorts of interesting questions like, well, why does that work? Are there other number combinations you could see breaking this problem into? Could you move those components around, like, for example, 30 plus 7 plus 20 plus 8? Does that still work? You might ask students if this works for any operation or just addition. All of these questions lead you to understanding what the student understands about this mathematical concept. And finally, you might have a student for whom computation is really difficult. So instead of computing accurately, they might be able to look at this problem and say, well, I'm not sure what the answer is, but I know that 37 plus 28 is going to be some number larger than 50. They might also be able to look at the problem and say, I also think it's going to be less than 70. All of this information is helpful because it takes what could otherwise be a really simple problem and expands it to reveal what students understand about the underlying mathematical concept. So now that we've talked about conceptual understanding and why it's important, check out my other videos. One is about the importance of conceptual understanding for students with mathematics difficulty or disabilities, and the other highlights the work we're doing in Project STAIR.